Hi guys, hope all of us are doing great. Today we're going to look at a different aspect of the concept of radioactive decay. And in our first video, I had promised that we are going to look at the concept of radioactive radiations. And basically, I've just framed this specific discussion in terms of characteristics of radioactive decay, that is radiations. And I hope it's going to be comprehensive from this specific perspective. So therefore, we're going to look at the characteristics of these various radiations that we mentioned in our first video for gamma, beta, and alpha particles respectively. Of course, I'd said that we are going to do individual videos on other aspects of radioactivity, which basically stems from this specific concept of a radioactive decay, and I mentioned a few of the electron capture, positron emission, and perhaps other areas which we had not mentioned in our first video. So for today, we're going to look at different various characteristics. And in order for us to achieve this, we are going to just have a short recap on some of the experiments that we have done in order to investigate the characteristics of this specific radiation and how basically its implication on this specific radioactive decay is going to affect the subsequent discussions that we're going to have on this. So therefore, we're going to look at in that one in a summary in a historical context of various experiments, and they appreciate the works of other scientists who are involved, and try to see how that one is going to, of course, assist us understand this specific topic. Now, the concept of radioactivity, as I've mentioned, is a continuation of work that was done basically by Antoine Becquerel. I hope this my pronunciation is coming out right for this part. This is the work of Anthony Becquerel, Henry Becquerel, that was done, which of course led to the discovery of this particular phenomenon of radioactivity. Now, in Becquerel's experiment, he found out that uranium compounds emitted invisible radiations, which of course blackened photographic plates, or rather they blackened photographic plates. And in some cases, we are going to see that he also discovered that these specific radiations, which were invisible ionized gases, for a specific case, they ionized a gas in a path that they were traveling. And then we're going to see also that from the works of Henry Becquerel's experiment, he observed that uranium crystals fogged. Now, this specifically for uranium crystals, they fogged, which means they created some kinds of a mist-like photographic plates in this particular sense. So from the observations of N. Becquerel's experiment, we're going to see that he predicted this aspect of radioactivity from this specific observation for blackening of what we call photographic plate, ionizing of gases in a chamber or a part that these particular invisible radiations were passing through, and then there was this aspect of uranium crystals of fogging the photographic plates, which led him to make a conclusion of this particular phenomenon of radioactivity. Now, apart from Becquerel, we are going to see that various other scientists will try to advance on and investigate on some of these activities that were being investigated, of course, led to other discoveries. And we're going to see the work of Maria Curie and her husband, of course, who was Pierre Curie, who together's work, of course, led to the discovery of radium and polonium. And they have done intensive investigation on these specific elements and tried to see some of the characteristics, the radioactive characteristics, which were contained in this specific experiment. Now, these are the two Nobel Prize laureates that we're going to see later. But of course, we're going also to see that the works of their daughter, that was and her spouse Juliet, also led to the discovery of other aspects of the artificial radioactive substances that we had mentioned in one of our videos. Now, this was achieved through bombardment of aluminium, and that process initiated a subsequent radioactive process, and therefore that one gave the concept of the neutronium series, which we had mentioned in our first video as one of the artificial processes of trying to achieve this specific radioactivity apart from the natural one. Now, of course, Maria Curie and the daughter Juliet and their specific spouses, of course, contributed heavily in the discovery of polonium and radium, as I said. And of course, there are other scientists like Ernest Rutherford, who had made a series of discoveries in different fields of radioactivity and, of course, in nuclear physics, which are going to complement on this specific area of describing the characteristics. Now, in Ernest Rutherford's experiments, of course, we are going to see that it led to the discovery of the alpha and beta, or description of alpha and beta particles that we had mentioned in our first video. And this, of course, is going to assist us also see how these specific experiments try to describe this aspect of a radioactive phenomenon. And there are various laws that we're going to see from these specific experiments of Ernest Rutherford, which are going to assist us to describe the various kinetic property or the various kinetics of this specific radioactive process. And we've done one of the videos on the symbol, of course, the kinetics of a simple radioactive decay in one of our videos. I'm going to put a link in the description boxes below so that we can be able to check on that. So the works of Becquerel and then Curious, and then we have what the Ernest Rutherford experiment laid a foundation and a basis for us in understanding this whole aspect of radioactive decay. And of course, those are going to assist us in pinpointing now these specific characteristics of a radioactive decay taking place. So therefore, I'm going to look at the individual radioactive decay processes and try to see how their characteristics are going to be described. So in this sense, I'm going to have an illustration on the board, which is going to assist us, of course, try to, of course, generally describe how these various radioactive processes or other products can be able to be described in a figurative way. Now, the illustration I've given on the board is one of the examples of the experiment that was done by Ernest Rutherford in trying to investigate the properties of a radioactive decay. And of course, in this experiment, he had a radioactive sample that is going to be illustrated using this specific part in the middle. And then here we have what we call a lead shield. Lead is an element, shield. And then we have this is a positively charged plate, which basically are going to form these two positive and negative charged plates are going to form what we call an electric field. And then, of course, when he was trying to investigate this, he found out that there was a deflection that, of course, was from this radioactive sample that we are going to see this specific point. There's a deflection that is going to go towards the negative plate. And of course, this one, he found out that this is going to be an alpha particle. I'm going to use this visible one. So this is going to be an alpha particle from the laws of attraction, as we said, from Robert Millikan, and of course the experiments that were done. We're going to see that this specific alpha particle that is being deflected towards a negative plate is going to have a characteristic positive charge. And we had said that, of course, this is going to be described as a helium nucleus that is going to be illustrated using that specific one. Now, there's this specific radiation that was not affected by the this electric field, and we're going to, of course, to discuss that one last. So we're going to have this one that was deflected towards the positive part of the electric field plate, and of course, we're going to see that this is going to have a characteristic negative charge. And of course, from the various product of a radioactive decay, this was presumed to be a negatively charged particle, and therefore this is going to be an electron that we can be able to describe using that specific notation. So therefore, from this specific experiment, this particular product, or rather the radiation that was not affected by this electrical field, was the gamma radiation from Ernest Rutherford's investigation. So in this particular sense, we are going to then therefore have a conclusion that in this specific electrical field, we are going to see the various characteristics being displayed by the three radiations for the alpha, gamma, and beta particles. So for the two, these are particles for an electron and a helium nucleus, and then this is going to be a radiation for gamma, which is a form of energy. So therefore, from this one, we can have a specific way in which we are going to distinguish these three specific forms of radioactive decay in terms of their characteristics. Now, of course, this is going to assist us in trying to find a way of describing these radiations in terms of their various properties. And of course, we are going to see that for the alpha particles, there are subsequent experiments that were done in order to complement on this effect on the electric field, whereby we are going to, of course, see that this electromagnetic radiations for the alpha particles, it's going to have a velocity that is ranging between 1.4 to 1.7 times 10. Of course, this is going to be 7 meters per second. Of course, we have decided that in our discussion on quantum mechanics, we had used this specific constant for the speed of light, and we had said that most of the electromagnetic radiations are going to have this specific velocity which we had assumed. And of course, the speed is going to be less than that. And of course, there was a particular argument that this particular characteristic is specifically unique for the wave, the wave particle duality concept, whereby the matter waves are going to display a different aspect. But in this specific case, for the radioactive radiations, they are going to have this characteristic as specific speed for the alpha particles of that specific value. And then these ones, for the alpha particles, they produce high ionization. This is, of course, trying to change the atoms which they interact with to form what we call ions, and that is the concept of ionization energy. Now, I've mentioned the concept of effect on the photographic plates, and for the alpha particles, they're going to have a feeble effect on photographic papers, and of course, they're going to be scattered by what we call heavy nucleus, or rather going to be scattered by what we call heavy elements. And one of the heavy elements, of course, we're going to see is gold, which is going to scatter this. And of course, this is familiar for us from the gold foil experiments that were done by Rutherford in order to investigate the characteristics of an atom. So in this specific case, that is to say simply a few characteristics of that alpha particles. And for the gamma particles, these are a form of electromagnetic radiations of a short wavelength. We have discussed various aspects of electromagnetic radiation, and I've mentioned a few aspects of this, and we say that these are basically forms of waves which have got what we call wavelength. So therefore, for alpha particles, they have a wavelength that ranges between 0.05 angstroms to, of course, 0.5 angstroms. And this, of course, we can see some very short type of wavelength. And this is angstroms, we have to say this power to 10⁻⁹ and meters, and therefore we can see from that particular aspect it is a very short type of wavelength. And from this specific experiment that was done, of course, we can see that the effect on the electrical field does not affect the gamma radiation, and therefore they are not charged and cannot be affected by either the electrical or magnetic field in that specific aspect. Now, these ones are going to travel at the speed of light, which are given as this specific constant. Of course, that we come across that is going to be the range under which the speed of apart from that, we are going to see that the gamma radiations are going to produce what we call fluorescence, and this is the glowing effect on some of the materials that we're going to see, like the phosphor that I mentioned in one of our videos as one of the fluorescent materials which find wide applications in our day-to-day life, especially in our households. And of course, we're going to see that they cause slight ionization. So the degree of ionization between the alpha and the gamma, the alpha particles and the gamma radiation are slightly unique in a sense that this one has got higher ionization capability, and this one is going to display a low ionization capability. And these specific radiations are going to have more penetrating power compared to the beta, of course, radiation, as we're going to see. Now, in this specific case, we're going to have different sources from specific elements. We're going to have different sources which are going to emit alpha, gamma, and beta radiation. For instance, I can be able to give an example for the alpha radiation. We're going to have radium-226 as one of the of course, nuclei, the nuclear that is going to, of course, an element that is going to produce the alpha particles. Now, for the gamma radiation, the cobalt-60, this is CO60. It's one of the sources of this specific radiation that we can, of course, pinpoint. So lastly, for the beta radiation, we're going to see that it's going to possess a negative charge. We had said basically this is going to be described as an electron, therefore it's going to have a negative charge and a mass that is equivalent to that one of an electron. These ones also are going to affect the photographic plates, and they're going to produce this specific nature of a fluorescence that I've mentioned that was observed in the alpha particles. And for instance, I can just give an example of a barium platinocyanide, which is going to, of course, produce this fluorescence when it interacts with the beta, of course, this kind of radiation that I've mentioned. And this specific kind of radioactive decay product, as we have seen for the alpha particles, it's going to be deflected towards the negative plate. Therefore, we can generally say that the beta particles are affected by the electric and magnetic field, respectively. They are negatively charged, as I've mentioned, and the high penetrating power are compared to the alpha particles. And of course, we can be able to see, and this particular case, with respect to the sources I've mentioned, we can just mention one of the sources of the beta particles as the strontium-90, which is going to be, now from our periodic table, I'm going to put a link in the description box. And I had mentioned the particular series for the actinides, which of course are going to display these specific characteristics of radioactivity as I mentioned in that specific discussion. So for today, this specific experiment is going to assist us, of course, complement on what we had discussed in our first video on the concept of various radioactive decays. And I promised that we'll try to look in a summary form on the various characteristics that I've mentioned in this specific video. Now, my last illustration is going to, of course, demonstrate on the various properties that I've mentioned, and a few especially concerning the penetration power, which is going to make a last bit of this specific discussion for today. Now, in this specific illustration, I've given the various penetration power of the various products of radioactive decay for alpha, beta, and gamma radiation. And of course, I've given for the neutron, which we're going to see later being the central part of what leads to the subsequent process of this radioactive decay. So in this specific case, for the alpha particle, they are going to be stopped by a thin piece of paper as they travel along the way. So therefore, we're going to conclude that relative to beta, alpha, relative to beta, gamma, and the neutron, they have low penetration power compared to these other three radioactive decay processes. And therefore, with respect to beta, we're going to see that beta can be able to penetrate through a piece of paper, but it's stopped by a foil of aluminium or a sheet of aluminium, as we can be able to see in this specific illustration. Now, with relative to alpha and beta, the gamma radiations, of course, are going to have high penetration power compared to the latter. And therefore, we're going to see that it's going to be stopped by a block of lead, which basically, this is this element that we have been mentioning. So it's going to be stopped by a block of lead as compared to these other two. So therefore, it has a higher penetration power as compared to this previous two that we have mentioned. And as we had said from the various characteristics, and therefore we're going to see that it has therefore a very high ionization energy and other aspects that we have mentioned. Now for the neutron, which is going to be a particle, of course, is going to penetrate through these three various aspects of paper, aluminum, and lead. And of course, it's going to be